form to graph. What would I do to put them in a good form to graph? What's the easiest thing to do to make an equation graphable? Isolate y. So for the red one, 3y equals negative 4x, y equals negative 4/3 x, right? What's the y-intercept? 0. And the slope is negative 4/3. So 1, 2, 3, 4, 1, 2, 3. And down 1, 2, 3, 4, 1, 2, 3. And there's my line. Yeah? We all know how to do that. Negative 3y equals negative 5x plus 27. Y equals 5/3 x minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 1, 2, 3. And there is my intersection, which you can quite plainly see is 1, 2, 3, 1, 2, 3, 4. Right? We can all do this in our sleep. These are easy ones. There's a reason they're easy ones, because I'm not trying to show you how to graph a system. We already know that. I'm going to use this information to show you why elimination works. Okay? So we've got our answer. It's written right there. We found our intersection. Now, listen, this is important. Pick a number between 1 and 9. Don't say it out loud, and don't tell your partner. Choose that number and multiply the second equation by that. This is the second equation. Multiply that equation by whatever number you choose, and then solve for y. So remember, solving for y means isolating y. So go ahead, choose that number, multiply the equation by it, and then isolate y. I'm going to turn off the screen and do that, so if you watch the video, you would see it all, or you're going to see all my work. Okay? Go. And you can choose any number between 1 and 9 or negative 1 and negative 9. Your choice. Now you should all be done, or getting close to. What do you notice? What do you find? Nathan? Bigger numbers, simplify it down, we end up with the exact same thing, right? Okay. So, I chose negative 3. You can see it right here. I multiplied everything by negative 3, and then I simplified, and I ended up back at exactly the same equation, right? So what does that tell us? Multiplying both sides of a linear equation, please highlight both sides of a linear equation, results in a new equation that has the same properties. Which means I can use it to do whatever I want, just like I could with the original equation. Because it's not changed in value. It's just changed in looks. Does everybody understand that? You may want to write that down here somewhere. Only the appearance has changed. He's on his field trip, right? Okay. Only the appearance changes. That is key. All right? The values and what we can do with that equation have not changed. Everybody cool? Okay. Here is the same two equations, yes? Right? Now, I said we want to add the new equation to the graph, but we'll do that in a sec. Let's deal with this first. If I'm going to add these equations, what do you think I'm going to get? What is 4x plus 5x? 9x. What is 3y plus negative 3y? 0. It's gone. Equals 0 plus 27. And then if I graph this, x equals 3, correct? Because if I divide both sides by 9, x equals 3. Everyone agrees? Now, you don't have to turn back and do this, but just watch. Here is x equals 3, yes? Where does the line go? Right through our solution again, yes? But notice it only gave us the x value of the solution. Why did that happen? Well, what happened to y when I added them? It disappeared. Or it was eliminated. Everybody understand? So, what happened? Well, one variable, in this case y, disappeared, and the remaining variable, which in this case was what? X, was half of the solution, wasn't it? Right? The solution we know to be 3, 4 because we graphed it. Everybody good? Now, what if x had eliminated? Then the remaining variable y would have been the y half of the solution. Everybody with me? Okay, now, this one's tricky. Subtract the equations. So what is 4 minus 5? Negative x. What is 3 minus 3? Positive 6y equals 0 minus 27? Negative 27. Yes? Everyone agree? Okay, now again, you don't have to graph it. I'm going to do that for you. I just want you to see what happens. So if I was going to graph this, I'd isolate y, right? So 6y equals x minus 27. Y equals 1/6 x minus 27 divided by 6 is 4.5, right? Minus 4.5. Everyone agree? Okay, don't bother graphing it, just watch. It was negative 4.5, yeah? 1, 2, 3, 4.5. Yes? And I go up 1 and over 6, right? So up 1 to 3.5 and over 1, 2, 3, 4, 5, 6. Where did the line go? Again, through the solution, yes? So what does that tell us if we are going to add or subtract linear relations? What does that allow us to do? Well, not necessarily. you get one value, right? Adding or subtracting linear relations results in either eliminating a variable or another equation which has the same solution. Now, which of these two is the one we are going for in this section of our text? Are we trying to create a third equation, or are we trying to eliminate? We're trying to eliminate. So we have to do the one that's going to eliminate things. Now, notice, let's do this last bit first. Could you tell me a third equation written right here that would have the same solution? I've given you two different ways to tell me a third equation. You write one down. There's three ways actually to find a third equation. Who can give me one of those ways? Nathan. Or what equation did you write down? Pardon me? 4x plus y equals 19. Absolutely correct. How else could he have done it? He could have subtracted, which would have gotten him what? 2x. No. Minus y. Plus 3y equals 17. Perfect. What else could he have done? Pardon? No, because I want a third equation that will have the same solution, so it has to have both variables still. Pardon me? He could have multiplied it, right? Any number, n times 3x plus 2y equals 18, or that same number times x minus y equals 1. All of those are correct. Is everybody cool with that? Any number you want. That's why I used n. All right, now listen. What this is saying, these 2 pages and this 14 minutes of talking is saying is the equations you are given are not necessarily the equations with which you must work. Do you understand what I am saying? You can change the equations to suit your needs by adding them, subtracting them, or multiplying them. Does everybody understand? What you have been given is not what you're stuck with. Okay? All right, let's turn the page over and see. Here's all the rules, just like I did for substitution. I'll start in red. Add or subtract the equations to get rid of one variable. Now, look at how we eliminated. What had to happen to easily eliminate? Look at this system and tell me what part of it made it easy for you to know we could eliminate. Rylan. Which? Right. This coefficient was the same, yes? One was positive, one is negative. So if I add them, they disappear, don't they? So let's have a look at where we are right now. Are there any numbers here that are the same but opposite signs? Where? 5 and negative 5, right? So if I add them, they will disappear. Agreed? So that's one of the things we're allowed to do, add the equations, right? So let's add these equations. That is step 1. So it's 3 plus 4. 7x. We know that disappears. Equals what's negative 9 plus 23? 14. Okay. Next, solve for the remaining variable. So what do I do here? Divide by 7, and what does x equal? 2. And lastly, just like in substitution, what do I do with that? X now equals 2. Where can I put it? Which x value? Any x I want. Now, we have been working with both of these this time, haven't we? So I can put that x anywhere I want, except there, because that's what got us the 2. We're not trying to find that anymore. We're trying to find y. So where does this go? Anywhere I want. I could go 3 times 2 minus 5y equals negative 9, which would get me 6 minus 5y equals negative 9, which would get me negative 5y equals negative 15, which would get me positive 3. Or I could do, in a different shade of green, 4 times 2 plus 5y equals 23, 8 plus 5y equals 23, 5y equals 15, and y equals 3. What is my final answer? 2, 3. Kid, did you do it right? You know you did it right. But what if you were like, I'm not sure? Can you check it the same way you check substitution? Yes. Now, if we did this one, we would only check this one, right? If we did the dark green one, we would only check this one. Everybody understand? Okay. Let's go to the next one. Sometimes you might need to do multiplication to make it work. Look at these two. Is there anything that's the same? No. What could I do right here that would make the x's work? Multiply by what? 3. And then, how would I eliminate the x's? Because if I multiplied by 3, I'd get 3x minus 6y equals 21. How would I then eliminate the 3's? I would subtract, in this case, instead of adding. Everybody understand? Now, what if I multiplied by negative 3? What would I get here? Negative 3x plus 6y equals negative 21. Now they're opposite signs. What would I do? Add. Everybody understand? Okay. Could I do this? Why does 2 work? Because that's going to get me 6x minus 4y equals 14. And there, would I add or subtract? 2x. Thank you. I would add. Everybody understand? Who decides which variable to eliminate? You do. Who decides whether you're going to add or subtract or multiply? You do. Right? So, what one do you want to do here? Normally I'd say everybody do it themselves, but we're still practicing. So which one should we do here? What do you want to get rid of, x or y? I personally... Oh, all right. I was going to make a joke about getting rid of my x, but never mind. I would never get rid of my x. I love all my x's. They're wonderful people. They just have poor choice, right? Because they could have been with this still, and they're not. Stupid. What are you going to do? All right, so we're going to eliminate y, we decided. Y. All right. So what do I got to multiply this guy by? 2. So I rewrite 2x minus 4y equals 14. And then we decided what? We're going to add. What's 3x's plus 2x's? This is not when I should hear silence. 5x, thank you. What is 1 plus 14? 15. What does x equal? 3. Where can I put that 3? Any x that I see. Right? Now, I would put it right there because it's just x. Right? That makes sense to me. Why would I make extra work for myself? So, 5 minus 2y equals 7. Negative 2y equals what? 2. So y equals negative 1. And what is my answer to this system? No. 3 negative 1. And then what do I do? No, I don't need to graph it. Where do I check it? Put it back in. Should I put it back into the top equation? No, the top equation is what I just worked with. Right? So I should put it into the bottom equation. What's 3 times 3? 9. What's 4 times negative 1? Negative 4. Is 9 plus negative 4 1? No, so what did we do? What did I do? 5. Why would I have put 5 there? Why is 5 right there? Because obviously I made an error. Why is 5 right there? What's right there? So what did I write there? 5. I didn't do this on purpose. I screwed up. I got no problem with screwing up. I'm not perfect. So is it a good thing we checked? Because how many of you wouldn't check? All of you put your hand up, because I'm about to give you a test on systems, and none of you are going to check them. You are all going to hand me in on your systems test. Not all of you are going to get 100%. Is there any reason to not get 100%? For not checking, right? So let's fix this up. I've made an error. So I fortunately have checked, and then we'll fix it. 3 minus 2y equals 7. Negative 2y equals 4. Y equals, what kind of 2? Negative 2. So now my answer is 3 negative 2. Let's check. What's 3 times 3? 9. Plus, what's 4 times negative 2? Negative 8. Is 9 plus negative 8 1? And now we're right. Now I would love to say that I wrote that 5 there on purpose to see if all of you would just copy it down and follow me along like, sheep. But I didn't. I just screwed it up. But I always check my systems. Why? For that precise reason. How many of you have ever put a negative in the wrong spot? Every one of you put your hand up. How do you fix it? You take 1 second to check at the end. Right? How many of you are planning to use all 80 minutes for your systems test? Don't one of you put up your hand. No, Nathan, you will not use all 80 minutes. You will finish early and you will talk to your friends like we all do on every test. If it is a 30-question test and you need to check 30 questions, how much time is that? 30 seconds. Is every one of you going to have 30 seconds on that test? Damn right you are. You're going to try to finish early to play extra Wordsmith or whatever you're playing on your phone right now. But really, you should be taking that 30 seconds to check, yes? All right, let's look at the other one. Holy barfaroo. What do I want to eliminate? They both suck, don't they? We got to change them both, don't we? To what? You want to eliminate the X or the Y? Y. I would eliminate Y. Why? Smaller numbers. What number do I want to get Y to that will work? 6. What would I multiply this guy by? 2. And that would give me 4x minus 6y equals 40, correct? Then what would I want to multiply this guy by? 3. To get 33x minus plus 6y equals negative 3, right? What do you see right there? There's our elimination, yes? Is it add or subtract? Add. So what's 4 plus 33? 37x. These are gone. Equals what's 40 plus negative 3? 37. What does x equal? 1. What do I get to do with that now? Apply it to which equation? Any of them. Doesn't matter. I'm going to put it with this top one, though, because the x is the smallest there. 2 times 1 is 2, minus 3y equals 20. Minus 3y equals what? 18. Y equals what? Negative 6. My answer, I think, is 1, negative 6. Now I check. I'm not going to use the top one because I've already done that. What's 11 times 1? 11. What's 2 times negative 6? Is 11 plus negative 12 negative 1. So are we right? Yes. Everybody cool? All right, now let's stop for a second. I want to show you a third trick for systems. Okay? It's not substitution, it's not elimination, it's a mix. Okay? Watch. You don't have to write this down. I just want to show it to you because it's kind of cool. Well, I think it is because I'm a math nerd. Sorry. If we were going to work with these, it would be a bit of a pain, right? Okay. But watch this. Everyone cool with that? Everyone's cool with that? Okay. Oops, sorry. Everyone cool with that? Now, what do you see right there? Y equals that, right? What do you see right there? Y equals that. So what do I know about the green box and the blue box? They're the same. So couldn't I write it like that? And didn't that eliminate Y for me? So if you ever see a system that is already set up with one thing isolated, you can always isolate for the other one and make them equal. Everybody cool? It's kind of a mix of substitution and elimination. Right? Because I moved it around like we often do for substitution, and then I used that to eliminate the Y. Everybody good? Don't have to do it. It's just something that you might see later on. Okay? Now, listen to me. You know that I just gave you a bunch of work on graphing, a bunch of work on addition or substitution of systems. Now I'm giving you elimination of systems. I want to look at it all together on Monday. Do you understand? Because they all work together, right? So over the weekend, I'm going to add page 247. Again, do I need to do all of these? No, but I got a few with different letters. You may want to try them because you guys seem to get a little shaky when I change the letters away from X and Y. I don't really know why that happens, but it happens. And I got another puzzle sheet. This one's not as good as the other one. And if you know the other one, don't spoil it. Okay? And on Monday, I want to discuss all three of them. Okay? Now, the more astute members of the class will notice there are only 2 more lessons. Right? Monday, Tuesday, review. And then we have Thursday, Friday, and Monday of next week to write a systems test and review for the final exam. Now, you have an option to write a cumulative on your last 3 units on the last day of class, Monday the 17th. Or I can use Monday the 17th to review for your final exam, which is coming up on the 18th, 19th, 20th. And you could write your cumulative on the 20th in the afternoon. Your choice. Discuss it amongst yourselves in whatever way you choose to. Majority will win, so be aware that if you don't get your choice, that's just the way life goes, right? I will take a secret ballot on Monday for your choices. Clear? What do I mean by secret ballot? You'll put a little piece of paper in a bin, and I'll count, so you don't have to feel pressured by your peers. What? Yes. Everybody understand? Pardon me? Graphing, or functions, graphing, and systems. Okay? You haven't gone over the graphing test. You don't know, well, you know what you got, but we haven't gone over it. I have 844. It takes 5 minutes to go over a test. Of course, why do you think I'm saying this? It will take 5 minutes to go over the test, take us till about 8:50, leave you with 40 minutes to work on this. Yes, I'm going to be taking your score out of 21 today as well, but not until we've gone over the test. I'll walk around and do that while I'm walking around seeing if people need help. Yeah? Okay. You. If you must. Yes? Yes. Pardon me? Yeah, I just talked about this with Olivia like 30 seconds ago. Okay. Yes. What? Okay.